So I will enable the trace, SQL trace first. Let's use the full trace. All right. And also I will use one more trace which will give me a bit more information. It's 10051. So this is called an OPI trace. OPI is the Oracle Program Interface. So basically, if client makes OCI calls, then on server side it's the OPI layer which receives these calls and calls whatever whatever functions like OPI exe when executing something, or OPI FCH or FCH2 when fetching something, and OPI whatever. So there is like open cursor, and there are a lot of functions like that. But I just wanted to illustrate what this OPI is. So basically, if the client says, let's say if the client calls OCI fetch2, then over the network the request arrives to the server, and OPI, the corresponding Oracle Program Interface function is called, which then will call whatever functions are needed to do the actual work. I had one question: am I going to post this to Enkitech.tv again? And the answer is yes. All right, so I will try to do it today. Okay, anyway, so I enabled this trace as well. Okay, so and let's do something now. Before that, let me just go to this trace file as well, and I will just do, I don't know, tail minus f on it, and okay, so what the heck have I done here? So okay, so anyway, so I don't know where I have a little init script which sets my trace file location based on some little logic. So but I can actually query VDollar process, I think. Yeah, in 11G or somewhere there is a field called trace file here. I just installed this database like 3 hours ago, so, or this instance, so that's why there's a little bit of mess. From VDollar process where adder equals select pattern from VDollar session where seed equals my seed. I have another little variable. So this is weird. Okay, anyway, so let me as you know, if you have been at my, if you've read my blog, you see that when Oracle doesn't make sense, or if you don't know where you query this information from Oracle, then you can always go to the OS level. I know my Oracle process ID is 9515, so I can just do lsof h2p files in Solaris 959515. So p files tells me where all the open files of this process. Okay, so and it's in the diagnostic home. So I have my scripts which kind of calculated this location. I think apparently were wrong. Anyway, so this is where I go. So we inevitably we managed to do a little bit of troubleshooting as well, even though I just wanted to demo you something different. Okay. Yeah, so I was searching for udump as well. Anyway, okay, so now we are in the right place, and we can do tail minus f on this guy. You already may see this here, Loopy I Call, and right. So I'm using my awesome Terminator terminal to highlight using a regular expression, like I did here. Okay, so let's run something very simple. Select star from dual. Okay, so this is everything you see when you do select star from dual. Okay, and you see we have 3 Loopy I calls. So basically, I mean, you may well remember that Oracle has operations like parse, execute, fetch, so on and on and on, right? So so every operation like this is a separate Loopy I call, right? And so and you already see there is a fetch happening here, right? And you see, I mean, SQL trace does not print anything out. I mean, most of the stuff SQL trace does not print out until this action is complete, right? Because when you look here, we are idle. My session here is actually waiting for the next message from client, right? And it actually is waiting, but it's not showing up here because you see this is the SQL net message to client. And again, the reason why SQL trace works like that is that when it prints out how long something took, or like the elapsed time, wherever it is, you see in microseconds, when it prints out something that how long something took, then it cannot print this out before this something has finished, right? Because it doesn't know how long something took before this fetch operation finished or this wait finished and so on. So I think this is an exception in SQL trace, and of course the Loopy I calls are exceptions as well because they are not SQL trace. They are from the Loopy I trace, right? So it's a different module, it's a different thing, right? But basically everything that has elapsed time in it, right, will including the wait, right, elapsed. These will be printed out only when the SQL trace when the actual operation finishes, and therefore, let's see whether we see anything useful here. I think I cannot illustrate this well enough with this output, but let me actually do this. Let's run one more thing. Actually, I'm not going to complicate it yet, but the thing with SQL trace is that as SQL trace prints out this operation when it completes, then any wait events you see, let's say we have, just before this blue line, we have a bunch of IO wait events, right? That any wait events you see, related to this fetch are going to be displayed before the fetch, right? So because this blue line is printed out when the whole workload or work for this fetch ends, right? So basically, if I want to know what kind of IO operations this fetch do, I have to look into the rows immediately before that, not after that, because after, but whatever I see after is gonna be some other next commands workload. Okay. So anyway, so this is a little bit of introduction. Actually, I think now is a chance to show. Just search for method R carry read trace or something like that. You will just go to methodr.com if you want to understand SQL trace well enough, right? So the structure and everything is detailed very well in there. Okay, so I don't know which exact white paper it was, but just go there. Anyway, so back to what I was talking about. So you might actually wonder that you see, what happened here? Let's start from the beginning. So I was, when I ran this a few minutes ago, I was, talking, and then I ran this select star from dual command, right? So if more than 10 seconds has passed since the last trace entry, writing, then the trace writing module will just write the new timestamp. So we would know roughly where we are from this as well. Okay, so, and then it marked that, hey, this previous wait, which lasted for 126 seconds, because this is in microseconds, right? So the previous wait ended now, and because I sent this select statement there, and only then the wait interface printed out this line, right? By the way, in 11.202 onwards, if I recall correctly, we are not showing cursor numbers here anymore, but cursor addresses. And there was a reason for that as well, but I've forgotten that. So somebody from Oracle mentioned it to me once. Okay, so but this is the cursor address. Okay, and I'm gonna stop here because we could go very deep here. I don't want to go on any more about that part. Anyway, so and the OPI call which came in, with the next request, which caused this wait to end, right, was a cursor close call. This is how SQL Plus happens to work. When you run a query, it opens the cursor, it runs it, it fetches it, whatever it needs to do. And when it reaches end of data, it does not close the cursor immediately. It actually closes it when you send the next command to it. So that will explain a few interesting weirdness is what you might see when you run your test cases in SQL+. You run the same test case in Java or something, it behaves possibly differently because SQL+ keeps the cursor open until you send the next command. Okay, so anyway, so this is why this is one database call, and another database call, and by the way, you see the OPI call came in. And now a little bit later, well, I don't know how much later, but let's say a little bit later, this SQL tracing engine now printed out that, hey, I'm closing this cursor with this address, right? Because the OPI call came in. And now the next OPI call was received, okay? And you might see that, hey, it's some sort of V8 bundled exec. What the heck is that? Actually, I've blogged about a lot of these things, so if you search for that, you'll get to my blog. But anyway, what this V8 bundled exec is that starting from Oracle 8, Oracle started supporting bundling requests together, like putting open cursor, parse, execute together, right? So, before Oracle 8, in Oracle 7 and before, it was only Oracle Forms who could do this kind of magic to reduce the number of round trips, right? Because it bypassed OCI and so on. It actually had its own interface, through the UPI, which is the user program interface or whatever it was called. But in OCI 8, Oracle allowed you to bundle multiple requests together. So that's why this will show up. V8 bundled execution. Okay, so basically within a single network round trip, Oracle could send parse. It printed out what statement we're parsing, then it started parsing, and once the parsing finished, it reported that, hey, I'm done. It took 1.3 milliseconds, and then it took the next request from the same bundle which was sent to it. So it will do it did execute. All right, and then ignore this right now, so that the SQL net message to client is sort of a fake event, actually, to be honest. So so it doesn't really send anything back or wait for us. It doesn't do any network traffic. So actually there is one more event which we can enable to see that. Anyway, so so Oracle does the parse, execute, fetch, and the first fetch all in the single network round trip, pretty much. Okay, so so it actually goes on. It closes the it doesn't close the cursor here. It just traces what the execution plan was. So that's a different topic. Plenty of different things going on here. But basically, when you see this means that Oracle sent a request back to the client, and also it ended up waiting for a reply from the client. So this is why it's called a bundled request. I constantly want to go deeper to explain a few more details, but I kind of am holding myself back because then it gets too complicated. All right, and after that, after this wait for the next message from the client application is over, then another OPI request has been sent in, which is fetch. That's how selects work, right? You open the cursor, parse, execute, fetch, 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 fetch. You just keep fetching more and more and more. Okay. And in SQL trace, if you read Carey's method R, articles, you'll see in SQL trace, the R here means that how many rows were processed. In other words, how many rows were returned by this fetch. Okay. Of course, we may have gone through millions of rows, but only one row actually fetched, matched our where conditions, so we are returning only one, right? It's similar for delete and update statements as well. That if you update one row, it will show r equals 1 here, right? Okay. So so this is the simplest example, and I'm going to run the same thing once more, but I will run snapper at the same time. I will run snapper on that session where I will just run this once. Okay. I just ran exactly the same thing. Okay, we have 3 OPI calls, right? And I wanted to illustrate you this. When you run snapper, you also see that the number of user calls was 3, right? So you might wonder sometimes that if you run a single small query, select star from dual, why does the user calls go up by 3? Well, this is the reason. We first closed the previous cursor in SQL Plus, and then we send the bundled execution, and then we do the fetch, right? It's basically we got 3 different requests, 3 different round trips, pretty much. Okay. All right. Okay, so if I see that there are some more questions and somebody is asking whether it's okay to ask a question or something, then yes, you can type in the questions here, so I will just occasionally pick them up. All right, so if you are on a recent version of Oracle, which is 11.2, there are a few interesting views. So $SQL command is something which maps to $session.command. So basically in session I think command is so basically this column shows a number in session, but if you join it to $SQL command, you will actually see what kind of command it is, right? So is it a select statement? Is it a whatever, flashback table or whatever? So in 11.2 you can access this from a view. Okay. I think there is nothing called OPI, but there is a view called $top level call, and this is basically all the OPI calls, all these Oracle program interface requests you see, these are documented here, right? Again, 11.2 onwards. So if you search query from top level call. By the way, if you describe ASH data in ASH, it's this field is there as well. I think maybe it's even in text, so you don't have to join it. So you can, well, let's just do it. Select top level call name, I think, count star seconds from $, group by top level call name, right? Order by to, right. Okay, so these are probably background processes who are idle, so I'm not going to go there how to diagnose that. But you see, we have a if you look into top level call names, we see what kind of operations are done here, right? So and I could break it down then, grouping by the SQL command to see what kind of command was it. Was it an update and delete and so on? Okay, so I will just go back to this. I will just scroll up. Just to show that Oracle has more than 100 all kinds of different commands that the client can send to it, right? And then and this V8 bundled exec, what we saw, is one of them. All right. I looked into one of the questions, and the question was that how come I see the close call before these parse, execute, and fetch, because if the cursor should be closed after all of this. And the answer is, I mentioned it earlier as well, that SQL Plus closes the previous cursor here. It doesn't close the cursor, but it's just about to open. Whatever was the previous query, it will close that. Right? You can use $open cursor to verify that. So you just can query that. All right. So let me just go on a bit. So I have a small table called T. I think I have. I just created it. Yep. You see what happened now? Now the screen is full of all kinds of junk, right? So this is again my query like I'm used to seeing it. However, before that, before even the parsing is shown, I have a lot of other stuff showing up. If I scroll up and to see what kind of statements I have, I can search backwards for, well, actually, oops. I can search backwards for the parsing, but I just will scroll up. Right. So I see just before my statement was ran, Oracle ran some other statement as well, right? So, but the clue is here. The recursive depth is 1. I mean, in order to run this query here, Oracle had to recursively run some other queries. Usually they are against data dictionary, right? If all the metadata what I need about this table is not in dictionary cache and library cache, right? But in this case, this hint already gives me away that in order to optimize my statement, what I issued, Oracle first recursively internally ran a dynamic sampling statement. Let me just see. It ran a dynamic sampling statement against my table, right? So it sampled some rows, and it then knew how many, knew some cardinality estimates and so on and on and on, and fed this information to the optimizer. So these are basics of the SQL trace reading. So I'm actually this session here is not about how to read SQL trace files. Read Carrie Millsap's paper about it. So, but I will just run this once more just to show that when the hard parsing overhead is gone, then this recursive stuff does not show up anymore. All right. So you see, my query returned 36 rows. I mean, if I look here, it returned 36 rows. So that's how SQL Plus approaches. So it will execute the query, then it will perform the first fetch immediately, because it's bundled together, and the first fetch returns 1 row. So SQL Plus works the way that it will fetch only 1 row first, right? Even if the table has more rows. And after that, it will fetch more, right? And now the question will be that, okay, how many more do we fetch at a time? Well, and the answer is array size. So in different languages or environments, and for different drivers you have different names, right? But all Javas and .NETs, and they all support specifying how many rows at a time should you fetch. Because if you need to fetch a lot of rows, you don't want to do it one row at a time. So that's why I set it to bigger by default. But let me set the array size to 3. Okay, let me just do it actually. Let's set it to 5. All right, this means that we will fetch 5 rows at a time. All right, so you see how nicely I managed to fit it onto the screen as well. So we had this bundled execution coming in with the parse and execute, and now let me just use r equals as well. Okay, so you can follow the first fetch returned 1 row, and now the next OrderBy I call came in over the network, and the next fetch returned 5 rows, and again 5, 5, 5, 5, 5, and so on, right? And you see what happened here. Again, we got lucky that Oracle returned 5 rows. So we continued scanning this table. We got 5 rows. We immediately sent them back. We did not go and check whether there is one more row or something. And now the next time my application came back to get even more, we reached the end of table, right? In my case, it's a single full table scan, right? We reached the end of table, so we sent back that, hey, end of data. We don't have any more data, right? We returned 0 rows, okay? And you see, so the stat lines here show basically the execution plan information will be dumped out here as well, with useful information like how many rows in total were processed in that execution plan line, and so on. Okay. Let's see, what else do we have? Vishal asked that will the logical number of logical reads be different with different array size? It depends. You see, that's actually a good question. So let's do that. So I'm thinking whether I should make it now more complex or not. And okay, let's do it more complex. I would say alter session set. Let's just show you that. There is another event called with the number 10,200, right? So I will just enable that as well. These are all for just playing around, right? So these are not really, or this particular event is not for everyday production use. But this will trace consistent reads as well. Not the current mode gets, but only consistent reads. But as I just do a select statement here, it's fine. All right. And let's just do this. So let's, okay, I'm gonna go here. I'm gonna run snapper. And I'm gonna run the same statement again. Okay. So let me now highlight OrderBy I calls and everything about fetches. You see, I used my regular expression here with the pipe, right? So when it's highlighted, it's either OrderBy I call or a fetch, and whatever else is either a wait event or just a logical I/O trace. Okay, so basically this logical I/O tracing allows you to it actually tells you that a logical I/O started for this particular block address, right? And later on it completed, right? So I can actually add together how many logical reads were done. Okay, so the thing is that we are returning only 5 rows at a time. Okay, so imagine now a full table scan happening. You will go to the first block, you will open the block, that's a logical read. You will read only 5 rows because you don't need any more. You will read only 5 rows. Then you will close the block, you will unpin it, and you will return the rows back to the client. You have to unpin the blocks. You have to clear these little internal locks, because if you are going to return the control back to the client, who knows when the client is going to send the next request. We don't want to keep a block pinned for 5 hours because the user went to drink coffee or something. Okay, so Oracle releases, there are, while Oracle can keep, let's say, enqueues and some mutexes for a long time. By mutexes, I really mean the cursor pins. Then other types of locks, like buffer pins, what you saw here, and then the latches and so on, they all must be released by the time Oracle becomes idle, and they must be released before we send something back to the user and wait for the next command. So anyway, so now if you imagine that if you take 5 rows, unpin the block and send the results back to the client, and now the client says, send me 5 more rows, right? Give me 5 more. Well, what do? You will go back to the same block because this block has more rows in it. You will reopen the same block again and take 5 more rows, close the block again, unpin, and then you send the rows back. So that's one reason why array size affects number of logical reads. You see, right now with array size 5, we did only 10 logical reads. So we must have, we likely, reopen some blocks. I can check how big my table is, but I think it's a single block table because it has 36 rows, right? So it fits into single block, but it has, reopened the same block multiple times. I can set the array size to 100. Oops, wrong window. Okay. I can set it to 100, so everything should be fetched in one call. Well, the first row is one fetch, and all the others should be in another. Okay, I will run snapper again. Right. With this, we only did 4 logical reads. So why did we do 4 of them? I mean, so this is actually how full table scans work. They do 2 logical reads on the segment header first. I don't know why it's 2, why they cannot do it in 1, but from segment header, you have to find out things like whether the table is valid. Is it the correct data object ID that you want to scan, and also the extent maps or they start from the segment header. Right? So where are that actual extents of that table or that segment? This is in the segment header. So Oracle does 2 IOs on the segment header, so or logical IOs, right? So that should show up here as well. It should list the reasons here. So I didn't want to go that deep. So let's. I'm not gonna try to troubleshoot that, but at least it tells you this block numbers. I can dump it and see which block it is. But anyway, so the reason why we don't see a 1 logical IO here is that when you do a full table scan, we first have 2 logical IOs on the segment header, and then we have the first fetch, which takes only 1 row, like you see here, and as that's how SQL Plus works. And then you see SQL Plus has sent another fetch, returning the rest of the 35 rows. Okay. So I will say set array size to 1, and I will run the same thing again. You see, when I set the array size to 1, I see 21 logical reads. You see, again, it's the same data. But why don't I see 36 or more? Because I fetched 36 rows. Well, the answer is here. OCI has some weird optimization in it that you cannot fetch 1 row at a time. Well, or maybe it's a SQL Plus thing, right? And the exception is the single case where right before the right after the execution, the first fetch will return one row. But anyway, even though I set the row array size to 1, Oracle still fetches 2 at a time. But still, again, for every of these, for every pair of rows, we had to pin the block again and unpin it again, and so on, because we cannot keep blocks pinned while the application is, while the database session is idle, doing nothing. So if this really hurts you for some reason, and you have to have this array size, well, let's see what happens when you do an order by. I just pick a random column to do order by, or for doing order by. So if you look into this, we start this parse the statement we parse execute and we do some work here, and now the first fetch finishes, right? And you see the first fetch for some reason took quite a long time compared to the other fetches. So this is actually where we do all this, basically. This is where we do the order by as well. So actually, for SQL statements, when you have an order by in it, then all the work is done here. So when you have an update or delete statement, then all the work is done in the execute phase. But for SQL select statements, all the work, I mean, if you have a blocking operation, around the whole query, like an order by in the end, well, all the work will be done in here. And you see the consistent reads figure is here. We did our 3 consistent reads. You see, and the other fetch operations did not do any consistent reads, because this operation fetched everything it needed into the temporary area, into PGA, or into the work area or temp, right? Of course, it's so small, it didn't go to temp, but it went to PGA, right, or private memory. And you see, when you fetch something into memory for order by reasons, okay, so now I gotta start again. So when you use order by, and this order by is applied here, it does not care about the array size, because when you have an order by, you want to order all the rows that come from the child operations in the query. So you don't care about the array size while you are doing this ordering in here. But once the data is ordered, this is when you start fetching it from the temp or your PGA a couple of rows at a time. And there are no consistent reads here, because in PGA the data is not in blocks anymore, it's just some array. Or better say, just some memory structure. Who knows what they're doing in there. All right. So, so this was the intro. I just wanted to kind of show you that how the parse, execute, fetch, and these are sort of related. And nowadays you can run an OPI trace, or in Ash nowadays you have these columns like the top level call and so on. Okay, so I will show you one more thing here because it's interesting. So I will just say create a table TL a clob. Okay, you see what I did? I just created a clob object, right? And let's select from it. Select star from TL where row num equals 1. So this is what I wanted to show you here. Lob file operations. So again, well, actually, let me just turn off the logical I/O tracing, because it's a bit too much. Okay, I again selected from the table which had a lob in it. All right, and again we see a similar thing going on here. We parse execute, And now we don't even fetch anything because I guess it's something lob related. So this is when we actually wait for the next command from the client from the client application. And now I don't know exactly why is there such difference, but it's likely related to this lob what I'm using. So apparently this query runs a fetch command, or this application issues a fetch command, gets one row back. And how lobs work, the regular fetch does not return lob data. That's why accessing lobs is very slow when you access it the wrong way with some SQL plus just and select with the select statement like that. But this lob locator is sent back to the client, and now the client uses this lob locator, and basically the client sends another request to the server saying that, okay, give me now data from this particular lob locator or from this lob item. And why I mention this is that SQL trace, you see in SQL trace there is a new field called lob read, but it's there since 11G or 11.2 or somewhere onwards. I actually have blogged about this as well. So SQL trace now tells you that, hey, we did a lob read operation which took 18 microseconds, right? But before 11G, SQL trace did not print it out. So if you had a lot of lob activity, then you saw a lot of lost time in the SQL trace. SQL trace told you you used only 1 second, but your job ran for 10 seconds. And this was one way before these 11G times, was just to enable this OPI trace. So then you saw all the other kind of operations and chit chat what happened between the client and server. All right. But now when I go on with the SQL plan execution, then I won't talk about lobs or any complex things like that. So there is one question that when we look into SQL trace, why does Oracle always show the same number? I mean, in the sense that, when I run another query, well, let me actually run it. You see, we have the same number. Okay, so this is because so this is a memory address. This is a slot in the open cursor array. So basically, if you close the cursor, like we did here, right? If you close the previous cursor and open a new one, then Oracle may easily pick the same slot in the open cursor array, right? Well, so I'm sort of tempted to show how this maps to, but I'm not going to do it. I'm going to write the blog entry about it. So there is a way to kind of figure out, a bit more details about this address, but I'll stop it there. So anyway, just like Oracle seed is the slot number in the Oracle session array, and you have the column called sadder. Select seed sadder from middle session. Seed equals my seed, right? Let me log out. I'm not going to log out because I want to trace. But if I log out and log back in, I might easily get the same seed and the same address because I just reused that slot in the logged in session array. And in this case, if we reuse the memory address in the open cursor array, we get the same number. So Louise asked that what is the difference in the commit and transaction commit? So calls. So in here, so select. Nope, sorry. Select star from $SQL top level call. Top level call. Okay. So with our top level call. So there is a commit here. So whatever this, when you have small numbers like that, this indicates that these features, or what you see here, were introduced in quite old versions of Oracle, right? Starting from 6, because that's when the Oracle major rewrite happened. Perhaps this is some auto commit call or something like that. There is XA commit, which is separate, and commit remote and sites, and some distributed database stuff, right? However, you see, this is transaction commit or rollback. Okay, let me just do this. So this is a little diversion here. So if I just say commit, you see, Oracle. I just sent a SQL statement commit. So basically, this is a SQL statement, and the contents of this SQL statement is commit, right? So Oracle actually parsed it and executed, and and it actually did not end up waiting for anything because I didn't have any transactions, any changes, right? Okay. Let me just do this rollback. Let's try rollback. Again, Oracle sent a cursor. This is a SQL statement, and the text of this SQL statement is rollback, right? So it parsed it, understood that it's a rollback, and it did it. Let me do this. Just say roll. You see, roll also does a rollback, but you see the difference. We did not parse anything. You see, here we sent the regular cursor. We sent the cursor which we had to parse, execute, and fetch. But if I hit roll, then Oracle does not do any parse or execute. It even, and this is the entry what SQL trace prints out when the transaction finishes, right? So if it commits, then the rollback is 0. If it rolls back, then it's 1, right? But anyway, so you see, the SQL Plus has actually sent us a OPI call saying rollback. I'm sure there is some argument, to this call, whether it's a commit or rollback, right? But you see the difference. So this is a special call inside or this special command inside SQL Plus, which doesn't send the SQL text rollback to the database, but it actually sends the direct OPI call, OPI commit, or whatever it's called. So we can actually try what happens when we do auto commit, and then I will go on. So let's see whether select causes a commit. Well, we don't see anything related. So let's do delete from T where row num equals 1. Aha. Let me just do it once more because the hard parsing overhead kicked in and recursive queries were displayed. All right. You see, again, when I run the delete with auto commit on, then we run the query. It does parse, execute, and there is no fetch here because it's a delete statement. There is nothing to fetch. All the work is done in the execute phase. And as SQL Plus had auto commit on, then right when the delete finished, it also sent a commit. But again, it did not send it as a SQL cursor, which had to be parsed and so on. But it sent the direct, it just sent a different packet, different command type to Oracle saying that, hey, do a commit. I don't have any cursors for you, just commit whatever transactions you have in that session. Okay, and you see then the SQL trace part logged that the transaction has ended with a commit. All right, so I'm going to go on and leave some questions to the end because otherwise I will go into these little details and not talk about the main topic of today.